Okay, we're going to start with a little bit of review. Let's say I wanted to find f of negative 5. So if I wanted to find f of negative 5, of course I just plug in negative 5 for x. Negative 3 times negative 5 is 15, plus 4 is 19. Now you guys did this last lesson, composite functions. Let's say I'm trying to find f of g of 3. First I plug 3 in to g of x. Which you see in blue. 1 minus 5x, 1 minus 5 times 3, or 1 minus 15 equals negative 14. So now I plug negative 14 into f of x. Negative 3 times negative 14 is positive 42. 42 plus 4 is 46. Now let's say I have some weird shape like a triangle, and be careful because these kind of things show up on the ACT where instead of a variable you'll just see a shape. Treat it exactly like you would any other variable. So if I were trying to find f of triangle, I would just take f of x and plug in triangle. And I'd have negative 3 triangle plus 4, or negative 3 times triangle plus 4. Now what if instead of a number, I put in some kind of term inside of f of x? So if I were trying to find f of x plus 2, what would I plug in for x? I'd plug the entire thing in blue in, the entire term, x plus 2. Now here you have to distribute because they're parentheses. So I end up with negative 3x minus 6 plus 4 in combined like terms. So my answer would be negative 3x minus 2. Now, what if I'm trying to put the entire other function g of x in for f of x? The process would still be the same. Put some empty parentheses, and instead of g of x, I would put in the value of g of x, 1 minus 5x. And again, distribute. And combine like terms. So f of g of x would be 15x plus 1. Note that in this case, your answer still has a variable in it, as composite functions often will. Note, f of g of x does not mean multiply f and g. So let's try a more difficult one. Let's say I have f of g of x. So my outside function is f of x, so that's the one I'm going to write the parentheses for. So x squared minus 2x plus 3. I just take the x's out and write parentheses, and insert the value of g of x, which is 4x minus 2. Notice that when I expand 4x minus 2, the quantity squared, I rewrite it as 4x minus 2, the quantity, times the quantity 4x minus 2. And then, in the second term, I distribute 2 times 4x and 2 times negative 2. keep in mind that 4x minus 2 squared expands to 16x squared minus 6x plus 4. And then you just combine like terms. And there's your answer. Now, if we're doing g of f of x, it's different because the order is different. So you're going to need to take f of x, or x squared minus 2x plus 3, and plug it into g of x, which is 4x minus 2. So the entire function goes in there. So now we substitute x squared minus 2x plus 3 for f of x. And remember to distribute. And then combine like terms. Now, is f of g of x equal to g of f of x? No. Because composition is not commutative, meaning the order that you do it in matters. Changing the order will give you a different result, as we saw. Now pause and try this on your own. Just kidding. Don't do that one.